Hi, I'm Rich Christenson. I'm a professor in the Structures and Applied Mechanics group in the Department of Civil and Environmental Engineering. So I'm the co-director here at the University of Connecticut for the National Institute for Undersea Vehicle Technology. The goal of the Institute is to conduct applied research to advance technologies for undersea vehicles. We have an NSF grant that has set up these preemptive advanced study institutes where we're taking a group of 16 graduate students and faculty mentors ultimately to 6 different countries around the globe to look at hazards and how other countries, how other cultures have prepared for natural hazards and how that preparation has fared in recent disasters. Earthquakes, tsunamis, storm surges, where we took a group of students from around the country and we spent a week in Costa Rica at the University of Costa Rica and traveling the country and seeing some of the aging infrastructure that they have in Costa Rica. It's a good opportunity for us to look at what our infrastructure is going to look like in the coming years. In addition to the marine structures that we look at, we also look at transportation structures, and so these can include highway bridges as well as traffic signal structures and sign structures, and look at buildings. Predominantly, we look at these structures and the response of these structures due to vibrations. So this could be traffic-induced vibration on bridges or wind-induced vibration of sign structures or earthquake vibrations for building structures. And one of the other aspects or things that we look at across all these structures is this new method of testing that's called real-time hybrid substructuring. And the idea is to physically test some components and numerically model the rest of the system, the rest of the structure.
I'm working on a project with Professor Christenson that involves a kind of novel structural testing method called real-time hybrid substructuring.
My role is basically doing everything from being in the lab and collecting data to processing the data and implementing it in the research.
One student is doing a real-time hybrid substructuring test where we're testing a superstructure of a building and we're numerically modeling the base of the structure. And it allows us to run a number of different tests with the same superstructure, but we can numerically swap out different isolators and do this quickly and test a number of different technologies on an actual superstructure.
It combines kind of what I think are the 3 main areas of engineering, kind of like theoretical understanding of something, being able to simulate something, being able to do an experiment on something. So I can kind of get my hands dirty in the lab, working on test equipment, and also get my hands dirty in the computer and code up some simulations.
This is a type of testing that has been, over the past 2 decades, applied for building structures and for seismic performance, looking at earthquake engineering applications. We've taken that and we've developed those methods and enhanced these methods and applied it to marine structures, we've applied it to space structures, we've applied it to building structures with wind excitation, and so we've done a number of advancements in these areas. And there's so much more potential that can be done with this type of testing.